Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Good evening to all teachers, parents and the wonderful students. So welcome to the Tuition Academy YouTuber, a joint venture with the eDidik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. Before we proceed, let's begin our session today with the recitation of the Ummul Kitab Al-Fatihah for the Muslim and for the non-Muslim a moment of silence. Al-Fatihah. So how's everyone? My prayer that everyone is in the best of health and ready to proceed for today's class. Before we start, let me introduce myself first. My name is Nun binti Muhammad Noh. You can call me Madam Nun, and I am your moderator for today's class. Together with us is teacher Suryati from SMK Sri Serdang as our host controller, and teacher Ayu, teacher Hafsah Ayu from SMK Sultan Sulaiman as our observer. Okay, so all of us here today to make sure that today's class running smoothly. So, and at the most important person today is our passionate and fantastic presenter, Madam Rosmaya. She is a very experienced teacher from SMK Yuhua Kajan Selangor. So let us give warm welcome to our presenter. Okay, for the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel and you also can visit channel Teacher Su, Teacher Hafsah Ayu and also my channel to get a lot of physics material, and not forgetting to subscribe the channel too. As usual, the lesson will be approximately 1 hour. The certificate link and the credit claim, okay, will be given at the end of this session. So remember that you can only use the email to claim the credit. For the credit claim, you need to collect the 1 letter and 4-digit codes, which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. So I would also like to remind students to use appropriate language and use appropriate profile picture if you wish to post comment in the chat box. I am pretty sure all students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. Stay focused, and if you have any question, please write in the chat box and we will try to provide you with the answers. Before I give Madam Rosmaya to present, I will announce the first code digit for the credit claim. So get ready, yeah? You're supposed to write down somewhere. So the first digit code is A6. Okay, A6. All right. So without further ado, please welcome Madam Rosmaya to start her presentation. Okay, thank you.
Hi everyone. Okay, so as usual, before we start, I'm going to introduce the PRIU teams in Academy YouTuber. Okay, so we have here, all here with us is all physics teacher, all physics teacher from matriculation and also from the STPM. So PRIU team usually, PRIU team is actually a joint venture collaboration team from STPM and matriculation. Okay, so I am the leader. So with us, teacher Non, teacher Ayu, teacher Su, okay, and also one more teacher, teacher Suhaya. Okay, next we have also Maths PRIU team, okay, Academy YouTuber team, lead by teacher Im. Biology, okay, PRIU team lead by Cikgu Faiza. And chemistry, PRIU team lead by Cikgu Shahnon. And perakaunan and ekonomi, PRIU team. But now they separate already actually, perakaunan, STPM and matriculation. So lead by Madam Fizi. Okay. So other subject is from STPM subject. We have pengajian MURID, pengajian perniagaan, perakaunan and a lot more actually. Okay. So I've posted the question that we are going to discuss today for semester 2 questions part 1. Okay, so at the end of this lesson, you will be able to learn the strategies in solving certain problems given. Okay, so you can download from the given link. Okay, I've given already actually in the description part. Okay, so you can get the question from there, and in the chat box also, I've posted the link for the question for you all to download. Okay, so we don't waste our time. So straight away we go to the first question. Okay, so if you done the question, you can write there in the chat box what answer you get, so that we can compare and check whether you got correct answer or not. Okay, for question 1, we read first the question. Okay, a potential difference of 10 volt is supplied to a cable with a length of 45 centimeter. Okay, in the electric, if the electric resistivity is 2.0 times 10 to the power of negative 8 ohm meter, so what is the current density in the cable? Okay, so this is the objective question, okay, from past year question. So what is given in the question? We have potential difference, okay, we use symbol V. We have length and we have resistivity. So the symbol for resistivity is rho, and we are going to find current density. So the symbol for current density, we use J. So what is the relationship between all this? Okay, looks like we need to combine a few more than one equation here. Okay, so I can see there. Okay, very good, Yong. You answered already. So you get A, the answer. Okay, the rest of you can join and write there your answer. So now let's check whether the answer, your answer given A is correct or not. Okay, so for resistivity, we can use equation R equals to rho L per A. Okay, from the equation here is easier to memorize as replay. So I like to memorize this, so I've told my students also for easier memorizing, we use replay. Okay, many of you answer A. So let's check whether it's the correct answer or not. Okay, now how to relate with J? So J, we have A here, so you can use J equals to IA. So I we can get from the V equals to IR. Potential difference equals to current times resistance. So you can substitute into here, and there we have here IA which can be related to current density. Okay. So from J equals to I per A, so combine all these three equations. So you get V per, here I is cross multiply JA, so you can cancel A and we can find J. So J current density equals to V per rho A. Okay, so you substitute into the equation 10 volt, resistivity 2 times 10 to the power of negative 8, and the current and the length 45 centimeter convert to meter. And okay, very good. You all get correct answer. Yeah, A. Okay, so you can mark yourself your answer there and check whether you can score more than 50, can score 100 or not. Full marks for the question given today. Okay, but we cannot discuss the. Hopefully, we can discuss all the questions given. Okay, so next we go to question 2. Okay, very good. You all got correct answer. So question number 2, you can jot down already the answer there if you've done. Okay, now question number 2, we read first the question. The drift velocity of electrons in an aluminium is 1.57 times 10 to the power negative 4 meter per second. Okay, the cross-sectional area of the wire is 4.5 times 10 to the power negative 6 meters squared. So assuming that the aluminium wire is supplied with one free electron by each aluminium atom. So one atom, one electron. One atom, one electron. So what is the current in the wire? Okay, so density of aluminium is given 2,700 kilogram per meter cube. And molar mass aluminium is 0.027 kilogram per mole. Okay, so you can write there in the chat box what's your answer, and together with us in the chat box Cikgu Faiza. Okay, thank you Cikgu Faiza to join the physics pre-U team here. Okay, so what is given? First, check. We label first what is given in the question. We have V, drift velocity, and we have cross-sectional area A, and we have we are going to find I, current in the wire. Okay, density is given. So for density, we can use mass per volume to relate with the number of free electron here. So you can use a mass per volume, and also molar mass is given, right? So you can combine these two actually. So for the molar mass, N, a number of moles, N is number of moles. So we've discussed this already in the SEM 1. So we just get the question, the equation from SEM 1. We discussed this already. So number of mole is given by mass per molar mass, or number of atoms per Avogadro number. So you can use this relationship to get the N, number of atom here. Okay, number of atom, which is one atom, one electron. So that means if we get number of atoms, that means we also get number of electrons. So memorize this, even though it's SEM 1, but we still use some of the we've learned in SEM 1 into SEM 2. Not just SEM 2, even in the SEM 3. Okay, so for the drift velocity, okay, we can use I never. Okay, I like to memorize this equation as I never. It's easier to memorize I never. So I equals to N. This N is not number of moles. In the equation I never, N is the number of electron density. Number of electron density. So Ne, charge of electron, V, drift velocity, and cross-sectional area A. Okay, so combine all this formula. Okay, so E, 1.6 times 10 to the power of negative 19. Okay, and then V, speed is drift velocity is 1.57 times 10 to the power negative 4, and the area cross-sectional area 4.5 times 10 to the power negative 6. So the problem is N. Okay, we have one student here, Yong. You get answer C, 2C. Okay, let's check whether you get it correct or not. Okay, so N, what is N? N is number of electron density. So that's mean per volume. Okay, so we can relate with here, we got volume. And the N here is cross multiply, you get M times Avogadro number per molar mass. So you substitute into here. From here, you substitute into here. And then the volume is mass per resistivity. Density. So be careful with the same symbol, same symbol. This one is density, not resistivity. Okay, so mass per density. Okay, so now we can cancel the M. So we don't need the mass of the aluminium here. Okay, so we simplify this equation. We get density Avogadro number per molar mass. Okay, so now substitute everything, and we get N already. Okay, so we substitute into INEVA here. So the answer is 6.8 ampere. Okay, Yong, you are the only one right there. In the chat box, your answer. So the rest of you, okay or not? Can you understand? So can give a sign by writing there, the chatting box there. You can say yes or whatever, you understood. But if you get the same answer, you still can write there. Okay, congratulations to Yong who get same answer here. Okay, let's try the next question. And if you have anything to ask, you can write there in the chat box too. Okay. Now we go to the next question, question 3. Okay, a battery of EMF 10 volt is connected to 4 resistors as shown in the diagram. We have 4 resistors here in this method, in this position, okay, given. So point X is earth, and the electric potential of point Y is, so we are going to find the electric potential at point Y. Okay, so what's your answer? Okay, can write there in the chat box. What's your answer? Join together with our with physics class today, and we check the answer. Okay, so if you observe like this, maybe it's hard for you to see how the arrangement here. So we can actually draw a equivalent circuit so that you can clearly see where this 4 ohm, 6 ohm and 8 ohm, we can find effective resistance from here. So can see or not? So it's become easier circuit, easier circuit to see. So 4 and 8 in one line of wire, so that means they are arranged in a series. So we can add the resistance 8 plus 4. And then the 8 and 4 together with 6 ohm here is arranged in parallel. So therefore, we can use 1 per R equation for R effective. And then we are going to find Vy here. So for X, the point X is Earth. What can be understood from here? Okay, if point X is Earth, automatically in your mind, you must know this, that electric potential X at X is equals to 0. Okay, that is what is meant if it is Earth. So point X is Earth, so that means Vx equals to 0. Okay, this is information you should know in your mind. Okay, so the Vy we don't know. Okay, now we are going to determine the potential difference between xy to get Vy. So before we find the potential difference between xy or across xy, better to use across xy. So that we can find Vy, so we need to find potential difference across xy first. So to find potential difference across xy, we need to find the R effective first. Okay, let's start now. So R effective for all this resistance, we use 1 per R. Okay, 1 per R. So 1 per 6 plus 1 per 4 plus 6, because 4 plus 6 is in series. Okay, so you get this, and we get R effective 4.0 ohm. Okay, so this one is 4 ohm. Okay, now look at 4 ohm and 3 ohm. How are they arranged? 4 ohm and 3 ohm are now in series, right? So we can use the shortcut method. We don't need to find I. No need to find I. That's a long method you've learned in Form 4, Form 5 secondary. So for STPM level, you can straight away use potential divider. Okay? No need to find I. So we use potential divider to find voltage or potential difference across XY. Okay, so we use ratio of resistance times the EMF here, 10 volt. Okay, 10 volt. So the ratio of resistance, we use 3 per total of resistance here, 3 plus 4. So that's mean potential difference across XY. Okay, the resistance involved is 3. So therefore 3 per 3 plus 4, total of resistance. Okay, times 10. Okay, this is potential divider formula. Okay, we can use potential divider formula straight away. Okay, so now we get potential difference across XY. Okay, okay, so you get 4.3 volts. But this 4.3 volts, so that means C and D is wrong. That means between A and B. Which one is the answer? We have negative and positive, right? Okay, so Young again, I saw there you get 3. You get what? A, the answer A. Okay, you get answer A. Why is it negative? Okay, so to know whether it is negative or positive, so you need to look at the direction of current. Okay, direction of current. So look at this battery, 10 volt. The terminal positive is on top. So that means the current flow this way. Okay, in clockwise, right? In the clockwise direction. Okay, so we know that current flow from high potential to low potential, right? How the current flow? The current flow from high potential to low potential. So starting from terminal positive here, positive 10, so that means it's decreasing until 0. 0. Then after 0 will become negative. Negative. So that means at point Y will be negative 4.3. And then lastly, back to negative 10, terminal negative of the battery. Okay. So therefore, correct, Yong. Your answer is A. Okay. Remember the concepts how the current flow. The current flow from high potential to low potential. So terminal positive here, positive 10 volt is the higher. Then it's going decreasing, it's decreasing 9 volt, 8 volt until 0 volt. And then again decreasing negative 2, negative 3 and negative 4.3. And negative 5, negative 6 until negative 10. Come back to the terminal negative of the battery. Okay.
Okay, Madam Rusmaya, can we announce the second digit code for the
Okay.
credit
So
claim?
your
Okay. So, hi students. So, our second digit code is 6. Okay. Our second
6.
digit code is 6. So, make sure that you write down the code somewhere. All right. So, we can continue, Madam Rusmaya. Thank you.
Okay. So next question. Next question, question 4. So in the figure below, okay, the switch K is closed. Okay, the switch K here is closed and a steady current flow in the primary coil. Steady current. So this is primary coil. We have soft iron core here. So which of the summaries below is correct regarding the magnitude and direction of the magnetic flux in the core and the direction of the induced current in the secondary coil? Here, secondary coil. When the switch K is open. Okay, so now the switch K is open. Okay, so when the switch K is open, so what happened to the magnitude of the magnetic flux, direction of magnetic flux, and direction of induced current? So anyone, if you got your answer already, you can write there in the chat box. Don't afraid to make mistake. If not sure, you can write there also. Okay. Okay, now we start with the question asked here, open. What happened when the switch K open? So when the switch K open, okay, so there is a changes in the current, right? There is a changes in the current and leading to changes in the magnetic field. Magnetic, because there is a changes in current, so there is a changes in magnetic field across the solenoid here, the PS here. So the B decreasing, at the time the switch K open. When the B decreasing from the magnetic flux relationship equals to NBA. So when the B decreasing, there is a changes also in magnetic flux. So that's mean from Faraday's law, EMF will be induced in the other coil here. Okay, so when the B decreasing, magnetic flux also decreasing. There is a changes in magnetic flux. So that means the A and B totally out now because the answer given here increases. Increase. So A, B out. So I now which one, C or D the answer? Okay, we go to the next level, next step. Okay, next step. We use grip rule to determine the direction of B. So current is this way from terminal positive, terminal positive to terminal negative. So in the solenoid here, primary coil here. So the direction is your thumbs, your four fingers should follow the direction of current. Okay, is to the right, to the right. Okay, so use grip rule. So that means your thumb shows direction of B. Okay, your thumb shows direction of B. So B is this way. So you draw it, B is this way. So that means direction of magnetic flux is PQRS. Magnetic flux is PQRS. So we have here two answers, PQRS. Still we don't know yet which one, C or D the answer, right? And Yongjun, Yongjun. Okay, so you have you answered D. Okay, so next step. We use Lenz law. If you say Faraday's law, EMF will be induced here because of there is a change in magnetic flux. Next step, we use Lenz law. Okay, Lenz law. Okay, so when the B decreasing, so how the changes will be. So the B resultant, the combination of the B induced and the B from the coil here, primary coil, okay, the combination will give you B increases from the Lenz law. The combination of B induced here and the B here, so B induced in such a way that the combination will increase back, the B, because the B decreasing, right? So the B resultant, the combination must increase. For the B increase, so the direction of the B induced must be in the same direction. Must be in the same direction, which shown by the blue line here, drawn. So in this direction. So next step, we use grip rule to determine the direction of current, because the question here, direction of current, right? So we use grip rule. Direction of B, we know already, same direction as the primary coil. Okay, so we use grip rule to get the direction of current. So B point downward because look at the arrow, blue arrow here, downward, right? So the B shows direction of B, your thumb. So the rest of the fingers shows direction of current. So which is to the left, to the left of the coil here. Okay, there. So now just follow the coil here. So coming out and from X to Y, because in the answer here given X to Y or Y to X, right? So the direction is X to Y. So the answer, your answer given D. Okay, very good. Okay, so congratulations. Who answer Yong Chun and Yong? Same name, Yong Chun and Yong. Okay, congratulations. What about the rest of you? If you cannot get, you just can join here saying, yeah, you understood why is the answer is D. Okay, so now we go to question 5. Okay, question 5. Okay, 3 long parallel wires carry equal currents into or out of the page at point PQR here. Okay, so we don't know into or out. Which one is the answer here? PQR, into or out. Equal distance from O. Okay, equal distance from O here. Which current in the wire will produce a magnetic field at O in the direction of OX. We want the current as to the magnetic field and resultant is to the OX direction. Okay, so cross means current flow into the page and dot mean current flow out of the page. Okay, so we got again from Yong, D. Okay, come the other student, the rest of you come join. What's your answer? You can write there in the chat box. Okay, so we start with the P. Let's say we can do try and error here. Because we don't know whether dot or cross first, right? So let's say we use cross. So the direction of B at point O will be tangent to the circle here because your forefinger shows direction of current. Your thumb shows direction of your thumb shows direction of current. Your four fingers here shows direction of B. So direction of B at point O will be downward. Okay, so R must be in the same direction of current so that we get direction of B upward. Direction of B upward. So you use your grip rule. So your other fingers, four fingers shows direction of B. So when you draw the circle here for direction of B, so at point O, tangent to this circle will give you upward direction for B. And you see they are opposite each other, so that means the resultant of these two will be 0. They are same magnitude because same distance, so the B is 0, right? So leaving only current in Q will give direction of B whether to the left or to the right as asked by the question here. They want direction of OX. So P and Q must be cross. Okay, P and Q are equal in magnitude and opposite. So when we add them up, it will give you 0 because same magnitude. Same distance means same magnitude. And given also equal currents, also I is same. You can also use dot, will give you upward and downward also direction. For B, if you use dot both, also you will get opposite in direction, same in magnitude. You can try also for dot. Okay, so now the Q, okay, so that's mean for dot dot cross cross, that's mean B is wrong. B is cross dot and C is dot cross. You see, so B and C is out. Okay, out. So remaining answer is A and D. We don't know which one because dot dot cross cross. Okay, can be dot dot, can be cross cross. Okay, so now let's try doing some more for Q. Okay, for Q, for the direction of OX to the for the direction of B to the OX direction. Okay, so that's mean Q must be dot. Okay, Q must be dot because when you use grip rule, so the direction of the B tangent to point O will be to the right. To the right. So you grip this wire which your thumb shows direction out of the screen. Okay, direction of current out of the screen. So the B is to OX. So that's mean direction of current at point what is that? Point R, right? Point Q. Okay, point Q is dot. So the answer is D. Because we get OX. Cannot cross because if cross we get to the left. So the answer is D. Okay, not?
Okay, Madam Rosmaya, would you like to take a break for a while for the
we take a break
advertisement?
now.
Okay, so everyone let's watch the advertisement first.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com Untuk maklumat lanjut,
Okay, Madam Rosmaya, I also want to announce the third digit code. Okay, so student, our third digit code for today's class is 0. Okay, please write down. Our third digit code is 0 for the credit claim. Okay, thank you so much. So Madam Rosmaya, you can continue.
Okay, so we continue with the next question. Question 6. The energy stored in an inductor is mu naught when a constant current flow through the inductor. While maintaining the cross-sectional area, the two ends of the inductor are pulled until the length of the inductor is twice the length of the original inductor. So what is the energy stored in the inductor? Okay, so energy of energy of an inductor. So what is the formula for energy of the inductor? Okay, anyone who've got the answer can write there in the chat box. So memorize the energy of the inductor, half Li squared. Okay, half Li squared. Now we are going to relate with the length, of the inductor when it is pulled until it becomes twice. So it must be related with the L. Okay, the L here is inductance. The L here is inductance. So inductance relate with the lengths we can have Luna. This is formula for inductance Luna, but still don't have L there. So we can use Luna or another one also Luna with small letter N, number of length per number of turns per length. Small letter means number of turns per length. So you can substitute into here, so you get two other equation for the inductance. Okay, Yong again, answer C. Okay, so let's check whether correct or not. So we have these three equations for the relationship to show the relationship between inductance and the length of the inductor. Okay, so which one to be choose? We choose the second one because we can have L here. L and N is constant. So the relationship only the changes. The changes is only between energy stored and the length. Okay. Mu naught is constant. N is constant because the same inductor, right? The same inductor. A is constant. Okay, this is state there while maintaining the cross-sectional area. So area is also constant. Current is also constant. Constant current flow there. You see, constant current flow. So the changes is between U and L, where U is inversely proportional to the length of the inductor. So therefore you can write using variation method you've learned in maths, variation topic, remember form 5. So U1 per U2 equals to L2 per L1 because inversely proportional. Okay, if directly here will be L1 per L2. So inversely, so U1 per U2 equals to L2 per L1. So substitute everything, the length become twice, so 2L1 per L. So mu2 U2 energy, we are going to find U2 and U naught is given there. Energy stored in inductor is U naught. Okay, so given. Then you cross multiply, cancel the L1, you get U2 equals to half U naught. Okay, so Yong, you are correct. You are correct. You get C. Okay, so next question. Question 7. Okay, we have 4 wires in a horizontal plane. Okay, each carry a current I, shown in the diagram below. So they cross each other. Okay, they're not touching. Okay, without touching, just cross each other. And point P is at the middle, okay, at the center of the square. And the magnetic flux density at P due to one wire only is B. So all of them, each of the wire has magnetic flux density B. Okay, so what is the strength and direction of the magnetic field at P due to all 4 wires? So we are going to find the resultant B at point P. Okay, so what's your answer? Can write there. So how to get? Again, we are going to use grip rule to determine the direction of B first. Okay, so determine the direction of B. So for the straight wire, the B is given by mu naught I per 2 pi d. B equals to mu naught I per 2 pi d because this is B formula for the straight wire. Okay, so now each of the wire we use grip rule. So first wire here, grip the wire. So B is direction is out, out of the screen, out of the screen. Okay, the next wire here on top, we use grip rule also. So at P, the B is into the screen, the green across there, into the screen. You grip this wire. Okay, we do the same for the wire, the other wire, vertical wire here. So you grip. So the shown by the dot cross, also cross, because you grip your other fingers, shows direction into the screen. And lastly, the bottom wire here, you grip this wire and it shows direction of B into the screen also. So that's mean 2 into the screen, only 1 out of the screen. So all give you B, magnetic flux density. So that's mean 3B minus 1. 3 minus 1 will give you 2B. Okay. 3B minus 1B. The all given magnetic flux density B. So that's mean 3 cross means 3B minus 1B. Okay, so what's the answer? 2B. But we have to answer B and D. 2B. So 3, the cross here is into. So into is larger. So that's mean it's into the screen is the answer, which is negative shows into the screen. Okay, so the answer is D. Okay. Looks like no one write the answer there. So got any problem, you can write there in the chat box. And I can see in the chat box there, teacher Nur Naini. Okay, thank you for supporting us, our physics teacher, physics class for today's class, teacher Nur Naini. Okay. And we go, if got any question, the rest of you got any question, you can write there in the chat box. If you understand, you can also write there in the chat box to show that you understand why we got the answer D here. Okay, next we continue with question 8. Question 8. Okay, so if no question, someone written there, I assume that you all understood. Understood the solution for question 7. Okay, so next we go to question 8. Question 8. A sinusoidal AC voltage of RMS value 8 volt is connected to a 500 millihenry inductor. So if the peak current flowing through the inductor is 30 milliampere, so what is the frequency of the AC voltage? So you are given 8 volts here. This is VRMS. And then we have 500 millihenry. So this is inductance. Okay, I can see there, Yong. Say understand. Okay. So for question 8, okay, Yong answered D. So let's check whether correct or not. Then we have current, current 30 milliampere, and this is peak current. So we see with symbol I peak here for peak current, and we are going to determine the frequency. To determine the frequency. So how to relate all these variables? All these quantities. Okay, so for the F here, we can use reactance equals to omega L, and omega is 2 pi F. So we can get F from here. But the problem is we don't know reactance. So we can relate with the other two. So for reactance, we can use V equals to Ix. V equals to Ix. So very easy to memorize actually, because reactance is a position to current. Okay, a position to current. So that's mean V equals to Ix. And then the pairing here to use is I peak, because this is I peak. So the V also must use I peak. Okay. If I peak, V also must I peak. If I RMS, the V here also must use RMS. Remember this equation. The pair must be the same. RMS with RMS, peak and peak. So I peak we use Vp, cannot mix with the VRMS given here. So we need one more equation, which is relationship between Vp and VRMS. You see? So 3 equations here. We are going to use 3 equations. So VRMS equals to V peak per cert 2. So substitute the V peak here. We get, VRMS here. V, this 8 volt. So you get V peak 11.31. And then now we do backward. So substitute into here to get the reactance. I peak is given 30 milliampere. And then after getting the XL, substitute again here to get the frequency. Okay. So inductance 500 millihenry convert to Henry. So we get frequency 120 Hertz. And I can see there who got correct? Yong and Xin Yue. Xin Yue. Okay. So what about the rest of you? You got the correct answer or not? Don't be shy to write your answer there. Okay, so now we go to the next question, question 9. Okay, question 9, we read the question together. Okay, so before we read this question, I can see Teacher Zana Ria, Teacher Zana joining us also. Okay, welcome. Thank you for joining physics class today. Support us. Okay, now we continue with question 9. Okay. So a horizontal wire loop ABCD with dimensions A cross B. Okay, A length and the B width of the wire. Moved at constant velocity V in a uniform magnetic field PQRS of 0.30 Tesla is shown in the diagram below. So the variation of induced EMF E against time is given in the loop is shown in the graph below. Okay, so determine the velocity of the wire and calculate the values of A and B, okay, the length of this wire and the width of this wire, and explain why the EMF is equals to 0 between 3 millisecond and 4 millisecond. From the graph, we can see that between 3 and 4 millisecond, the EMF is 0. So why it like that? Okay, now we go to A first. Determine the velocity V of the wire. Okay, so we are going to relate these two. Okay, at the moment the wire entering the magnetic field. Okay, so what happened? Okay, so the wire will cut the magnetic flux. Will cut the magnetic flux from the B here, right? Magnetic field. So there is a changes in the magnetic flux linkage, right? So that means the EMF start to induce in the wire here. So given by the graph here. So the E suddenly become negative 40, right? 40 millivolts. So this is the starting point at the moment the wire here entering the magnetic field. Okay, this part. And then from 1 to 3 millisecond, okay, this is the process going until all the wire, all the coil here, loop, all the loop here entering, all the loop here entering the magnetic field here. Okay, this 3 second, 1 to 3 millisecond, and then 3 to 4, it constant, right? Is no EMF induced. So that means all of the coil already inside the B. Okay, all of the coil already inside the B. Okay, so now we can use this D 3 centimeter, okay, to find the speed, the speed or the velocity, because velocity is distance divided by time, right? S equals to Vt. Okay, so the speed is distance divided by time. So distance is speed times time. Okay, so starting from here, entering. So this is the point. Okay, now it moved until the other side of the magnetic of the B area here. So until it reached 4 millisecond. So this is time taken 4, time taken 4 millisecond, and the distance it traveled is 3 centimeter. Okay or not? So from this distance and the time, we can find speed. Okay, very easy actually. Just need to understand the process, MF induced. Okay, from what you've learned in Form 1, Form 2, Form 3, now relate with the Form 6 level. Okay, so from S equals to Vt, S is 3 centimeter, and the time taken is 4 millisecond, convert to second, and you get the speed 10 millisecond. Okay or not? So I didn't see anyone right there. I don't see anyone right there. The answer for A. Okay. So can you all understand or not why the answer is 10 meter per second? So this is the speed of the wire. Okay, next we are going to calculate the A and B, length and width of the wire. Okay, so the wire the width entering the what you call this B first, the B entering the magnetic field first, and the B is perpendicular to the B, to the magnetic field, So the MF will induce in the B, the width of the coil. Okay, that is what you need to understand. So the B here is perpendicular to the magnetic field, so therefore the B will be induced in with B of the coil here. Okay, it's entering first. Okay, so now the part for B, okay, the B here, we use, because MF is induced, so it is a straight wire B, so we use this equation BLV. Okay, we derive this equation already. So you go back, do revision and find where this formula comes from. You need to know how to derive also. So BLV. So the speed here calculated already, right? 10. So L is the length, B means the B, and the magnetic field B. So we got everything given. So 40 MF induced is 40. Read from the graph here. Convert to volt, and then B is 0.30 Tesla, and B is the wire here entering the B magnetic field, and speed is 10. So that's mean the B is 0.013 meter. Okay, so you can calculate the B 0.013 meter. So done for B, and explain why. Okay, we we haven't finished yet. A, now to calculate A. So to calculate A, we look at the part where the A entering from the PS to QR, but not reaching QR yet. This is the time taken here, 1, 2, 3. Okay, 1, 2, 3, A to B, when the full coil entering the B here. Okay. Okay, so look at the animation here. Can see or not? So it doesn't reach QR yet. So this is the time taken, 1, 2, 3 second. Okay, 1, 2, 3 millisecond. This is the time taken, but the speed still maintain the same, 10 meter per second. So we use the time here, and the distance here is given by the A. So the distance here given by the A. So S is A, and V is the speed, and the time taken is this one. Okay, 2 millisecond. Okay, understand or not? So we can calculate A, substitute V and T. So A is 0.020 meter. Okay, easy, right? You just need to relate the concept, the concept of physics used here, to the formula S equals to VT. Okay, I can see also together with us, Madam Fizi. Okay, join us. Okay, so thank you, Madam Fizi, for joining us physics class. Okay, so we continue with question C. Question C. So explain why the MF is equals to 0 between 3 millisecond to 4 millisecond. So after the coil here entering the B, then continue to move Q to R. So the coil experience a constant magnetic field. So there is no changes in magnetic fields. That means no changes in magnetic flux linkage. Remember the Faraday's law? When there is a changes in magnetic flux linkage, there is a MF induced. But you see here, 0 reading for the MF. So that means the coil is in the constant B. Constant B. Okay, flux linkage with the wire ABCD is constant. That's the answer. Right? 1 mark only. The question. The question. Okay, so if you have any question, cannot understand, can write there in the chat box. And if you understand, also can write there. Because just to check whether you my presentation actually you understand what I'm explaining here. Okay, Yong. Thank you, Yong. You right there, I can see, understand. Okay. So next we go to question 10. Okay, question 10. We read together the question. So anyone can answer this question, can write there in the chat box. Okay, an electron is accelerated from rest by a potential difference of 410 volts. Oh, we have Cikgu Syafiq there. Thank you, Cikgu Syafiq, for joining physics class. Okay, so okay, no Syafiqah also. Okay, you understand. Okay, now we go to read this question again. An electron is accelerated from rest by a potential difference of 410 volt. It then enters a uniform magnetic field of magnitude 300 millitesla. So here is the magnetic field 300 millitesla with its velocity perpendicular to the field. So calculate the speed of the electron. Okay, so the electron entering the field here with this speed, we are going to determine, and it form a circular path. So we are going to determine the radius of this path of the in the magnetic field. Okay, so we do the first one, speed of the electron. So you are given 410 volt potential difference across here this part. Okay, then electron, so it is understood that if electron, it has charge 1.6 times 10 to the power of negative 19 coulomb. Okay, what else given? And then the B, the B. Okay, calculate the speed of the electron. So to calculate the speed of the electron, so we use how to relate this V and this potential difference across here. So what are we going to use here? We use work energy theorem. Work energy theorem. Because electron here is accelerated by the potential difference here. So you can use work equals to QV. Actually, it comes from the what you call that principle of conservation of energy. From the work energy theorem. So you can use EV equals to change in kinetic energy. So energy electron is accelerated from rest to a velocity, this velocity V. So you can use half mv squared kinetic energy. This one is from the work energy theorem or principle of conservation of energy actually. So EV equals to half mv squared. So you cross multiply to get V. So V is square root of 2E V potential difference per M. Make sure when you write in the your answer, you use one V small letter, the other one is capital letter. Make sure the examiner can distinguish between these two V because they are same letter, right? One is capital letter, the other one is small letter. Okay, so now substitute everything into here, and the mass is the mass of electron. If not given in the questions, sometimes given in the data booklet or in the constant constant at it's written in the page at page, I forgot already which page the second page or the last page given to you. So this is a constant for M. In your calculator also got, right? Mass of the electron, okay? In your calculator. So this mass of electron. And the answer is 1.20 times 10 to the power of 7 meter per second. Okay, I cannot see anyone there write the answer. Okay, so hopefully you all understand. Okay, now we go to question B, radius. Okay, if radius and then this is a circular motion. So remember the same one you've learned. Same one you've learned the circular motion, centripetal force. is provided by the magnetic force. Magnetic force, because the electron move in the magnetic field. So the centripetal force is provided by the magnetic force, which is given by the QVB. This F is QVB equals to mv squared per r. So you choose mv squared per r. We have mv omega and we have mr omega squared. So we choose mv squared per r because we calculate V already here, the speed. So we choose this one for the centripetal force. So QVB equals to mv squared per r. Cancel the V, one of the V. So you get, rearrange the equation. So you get R radius equals to mv per QB. And substitute the value of mass of electron, V the speed, this speed, and the Q charge of the electron, and lastly the B 300 millitesla. Convert to Tesla. So you get radius 2.28 times 10 to the power of negative 4 meter. Okay, so also no one answered there, but it's okay. I hope you all understand. Okay, I think that's all the question, right? Okay, finally we managed to finish all the 10 questions given to you all. So I give back to our moderator, Cikgu Non.
Okay, thank you so much, Madam Rosmaya. Alhamdulillah, we have reached the end of today's session. Congratulations to those who can follow our session from the beginning till the end. Before we end our session today, I will announce the fourth or the last digit code for the credit claim. So the digit code is 7. Okay? Make sure that you have complete digit code. Okay, so all of you, please stop posting your comment for a while, and if you haven't clicked the subscribe button, please do so. Make sure it turns to gray color, and also activate the icon bell so that you will not miss the next class session. Then if you find that the lesson was beneficial, click like and share to your friends and your social media. Spread and share dedication in joining the free online class today. Okay, link of certificate and link to the claim credit are already given in the checks box. So with the access code of hashtag class AYU EDD. Please take note, the link will end half an hour after the live. Make sure to use the EDD email only to log in. Okay, incorrect email use will not be entertained. If you haven't got one, please apply. The link to apply the EDD email is given in the chat box. So if you wish to get more information on the online classes, go to www.academyyoutuber.com. And to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all students for joining our tuition class today. Remember that the more classes you join, the more credit you can claim. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout the Malaysia for all students throughout the country. Thank you for being a YouTuber Academy supporter too. I think that's all for now. See you in another session. Do not forget the hashtag bermula percuma, selamanya percuma. Stay safe till we'll meet again next week. Same day and same time. Thank you very much and Assalamualaikum. Bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.